There we go. We are live. Okay, so this is DB Hangops, September 4th, 2014. It's 11 a.m. Pacific. And today we're going to be talking, well, today we were supposed to be hopefully talking about archery indexes, but I just found out that Matt Lord is, I guess, out of the country right now. So we'll probably start with some talk about index fragmentation, which is something Shlomi had asked about a couple weeks ago. And then second thing on deck for today is talking about networking. Just what level of networking does a DBA need to know, or what kind of things should a DBA know? How comfortable should a DBA be with TCP dump? Things like that. So we'll kind of work that out. But real quick, let's go ahead and do a quick round of introductions. So I'm Jeff. I'm a DBA at Box, and let's go with Jeremy. Go ahead.
Hi, I'm Jeremy. I'm a senior DBA at Etsy.
Okay.
Tim?
Mark.
Hey, I'm Mark Leaf. I'm a development manager in the MySQL group at Oracle.
Okay, Morgan.
Morgan Tucker, MySQL Community Manager at Oracle.
Okay, Shlomi.
I'm Shlomi. I'm engineer at Outbrain.
And Tim.
I am Tim Callahan from Tokutech.
Okay, so without further ado, Shlomi, go ahead and take it away with your index fragmentation. You asked for it.
Okay, cool. So present the topic. What is index fragmentation? B trees by nature. In a couple months ago, I think we discussed the creation of indexes and how B trees are built. And B trees by nature tend to be fragmented. So there's a lot of holes within. They're not as optimized space-wise as they could have been if we were to manually produce them. And a topic I want to discuss is how to handle index fragmentation, if we need to handle that at all. We know that it's good to input data into an InnoDB table by ascending primary key order, and probably the most important reason for that is that as you input data in ascending PK order, the index gets very little fragmented. It kind of trusts you that you're doing the right thing and doesn't split as many pages as it usually would. It says, okay, you're putting 2 and then 3 and then 10 and then 15 and then 20, and I'm getting a good feeling with that. I'm getting positive vibes from you, so I'm going to trust you, and I'm not going to split a page, an index page, just as soon as I would normally do, but I'm going to trust you in this and leave only 1/16 of the page empty and then rush on to the next page, etc. And that's great because we're typically able to actually control the order of inserts into InnoDB tables primary key-wise. But then what happens with the secondary keys? So if I have an auto increment primary key, what happens on the secondary key, which is on some string or something that has no relation to the auto increment order? In this case, those indexes tend to be fragmented. And the question is, what do you do, if you do at all, to prevent that or to heal that? And just before discussion goes on, I have in the past experience or evidence through Pecona server that has the InnoDB index stats table that InnoDB is very good at shrinking back that fragmentation. As you delete rows from an InnoDB table, it's doing pretty much the right thing and merges back as much as empty pages as possible. So this is good grounds for discussion. And many people ask, should I recreate an index? Should I rebuild an index on a table given that there is fast index creation, etc.? What do you guys do about that, if you care at all?
It's a great question, Shlomi. It looks like Mark also wants to clarify. I just wanted to mention the index stats you mentioned are in MySQL 5.6 as well. And having that diagnostic information available, where you see something related to rows to pages physical, it's got other interesting ramifications when you want to think about page size and other stuff. It's really good to have that. That was just my comment.
Okay, well, I guess I can jump in. It's actually kind of an interesting topic in just figuring out how to actually how to measure this, and that's the ultimate thing is, we can talk about it and we understand that insertion on primary key order is obviously kind of like the best bet for getting your good fitting of pages and things that will go into your buffer pool cleanly and kind of move around in a nice way. And so given all that, just trying to figure out how do you actually identify index fragmentation? Does it manifest as kind of the table is growing very large, or maybe the performance of your queries or things against a given schema aren't working as well? And so the thing is, personally, I don't think we have any sort of way to actually capture that, and it's kind of under the guise of, until you had mentioned it, Salmi, I actually never really thought about it, and it's more because we alter the tables well or often enough, I guess, that the things are ultimately being rebuilt anyways, and since we're using online schema change, things are mostly done in primary key order. So it's kind of that's how it is on my side, I guess. But I would be curious to hear if anyone else actually has a way to identify this as being a problem, or if they have some sort of measurement that can show an actual change in performance based on that.
I have a question specific to InnoDB. Shlomi was mentioning when you're loading your data, I assume there's some kind of value for splits and merges, as it relates to a B tree. So at some point, Inno probably doesn't want to pack the entire 16K with data. It wants to keep a little space around. When it reaches that kind of high water mark, it might split the page into two, and then on the reverse, as you're deleting data, at some point when there's adjacent pages and they have collectively enough empty space, it might be merging them together. Are those two values settable in Inno or tunable, or are they fixed at two different numbers, and then that's the way the system performs?
I don't believe you can set them with a variable. I think they're hard-coded, and I don't know what they're hard-coded to off the top of my head.
Okay, but they're fixed, in other words.
Yeah.
Okay.
On the initial page fill factor, which is something Shlomi mentioned, it's 15/16. On when to split, it's when it's full, and when to merge, that's not something that's configurable. And I know Facebook's been doing some work in this in their engineering team. The summarized version of that I don't have, but people are looking into it.
At least the theories, what you would get from the academy is that if the page is half full, say it otherwise, when it turns full, it just splits into two pages that are both half full. And when two adjacent pages are both less than half full, they should merge back into one almost full page. Is that the way it works within InnoDB roughly?
I think that's pretty much the way it works.
Cool.
And there are database systems that let you set the page fill factors and things like that. I know that Oracle does it, for example. You can very finely tweak how things are filled in the pages, but we don't have that in InnoDB.
And Jeff might have been hinting at this briefly. I assume, given the people on the call right now, these 15/16 and other values with a 16K page size in Inno versus if someone were using, say, 4K pages, the user experience, how does it make things feel different in production, in benchmarking? Because I'd imagine 15/16 on a 4K page is much smaller than on a 16K page.
Yeah, I mean, you ultimately, it really depends on row sizes and things like that. At the end of the day, it's how many rows you get into the page itself. And with 4K, you've got compression on top and all of those kind of things to think about too. So, I mean, typically with the smaller page sizes, people are using compression, and that will affect the overall performance in production and benchmarks, because you have to have the compression overhead that gets put in there as well versus non-compressed pages with a vanilla 16K page, right? So I mean that's probably the biggest amount of overhead. Otherwise, I wouldn't say it's noticeable from any other factor, like the number of pages or anything like that you might have to have, for example.
Jeff or Jeremy or Shlomi, do you guys, independent of compression, are you using non-default InnoDB page sizes on your production systems?
Nope, we're running the default 16K right now.
Okay.
We use only 8K pages. We use compression with 8K pages. We'll suffer a little bit from the compression CPU overhead, but that's not too terrible with 8Ks. And on the other hand, we gain roughly 50% gain in disk space. So it's almost always compressed tables with the default 8K.
Got it. And actually, Jeremy, I'm curious on your end, like just the initial question, like have you ever considered anything around index fragmentation or, having that dictate any sort of work, I guess, on your side operationally?
No, pretty much all of our workload is primary key lookups, so we very, very rarely use secondary indexes, so it's never been a concern for me.
Cool. Okay.
That is something I never managed to get to. I mean, getting a workload that is almost primarily primary key lookups. I never got to do that. There's always a secondary index which I must go through. More complex queries. That's awesome. Is there a secret sauce?
No SQL, Shlomi. No SQL is the secret sauce.
The grass is greener on someone else's pastures. Shlomi, one thing I did want to mention from your initial speech that I found historically interesting is fragmentation can happen very frequently, or could happen very frequently, in secondary indexes rather than primary key indexes.
Yeah.
And suddenly, with fast index create, and with that being online now, this is useful because as primary keys often insert in order, secondary keys do not always insert in order, and they can take significantly more space. So fast index create actually sorts the index before it builds it.
So would you periodically drop a secondary index and recreate it using fast index creation just for a line, just for compressing the defragmentation?
I wouldn't. I mean, I'd try and get some diagnostics to be able to tell that was the case. But in the previous mode of operation, any alter table would, have an empty definition of the new table and then trickle load row by row what would probably be in order of the primary key, but not the secondary keys. They actually start out fragmented. And now you can do a batch insert, and then you can add the secondary keys in after. You start off with a better page fill factor without that fragmentation. And I think this is a change that's not been discovered by everyone, but very useful that happened in the 5.5, 5.6 time frame.
So a question for you guys: are you pretty much all using an ODB file per table, or do any of you use single, the single big table space?
Also, file per table here, definitely.
File per table.
I said goodbye.
I'm actually curious. So, Mark, I mean, are the semantics different?
Well, there's two different levels of fragmentation, right? There's fragmentation of the index itself, and fragmentation within the table spaces themselves as well, right? So if you've got a single table space with all of your tables and indexes being created in the table space, they typically grow in blobs. So they'll grow for the first 64 pages, a page at a time, and get allocated through the data files. And then they'll grow in 1 megabyte extents as the table grows further as well. But there's no guarantee that those extents are actually contiguous within the single table space data files as well. So what can happen is you will have like a 1 MB chunk up here and a 1 MB chunk down here, and it keeps on going down as they get allocated. So you actually end up with fragmentation through the actual data files themselves. And you can try and alter the tables and try and get lucky if you have enough free space in the data files themselves to get contiguous allocations of the actual indexes or table data themselves as well. So that's a different kind of fragmentation, but it helps if you're doing anything like index scans or scanning large numbers of rows across extents and things like that. You don't have to seek through the files themselves. You just can consistently read in a portion of the file instead.
Well, Mark, if I'm not mistaken, you have that same problem with file per table, because the file system below there might not be contiguous. They'll be 4 megabytes at a time.
Everything at the file system level, yeah, and especially with file per table as well, because file per table extends, in a much finer grained manner, right? As you have to actually have to extend the data files. Typically, with a single table space, you'll allocate this, a huge amount probably to the table space data files themselves, and start filling in the data to fill in the data files themselves. A normal, file per table one will start off at something like 32K or something. It's a couple of extents or pages in size, and then constantly grows after that. And you can't guarantee where the hell that's going to be on the disk. So there's benefits to both sides of it, right? You get less fragmentation through the data files for something like a file per table space, but probably more fragmentation on the disk level, and you can get less fragmentation on the disk level, and you can try and work things to try and get things contiguous on the single table space level. But you can also end up with a much more fragmented set of objects in a single table space, but with a lot of shared tables. They're both things to consider when whether you're using one or the other.
When I see a database without DB file per table, my only desire is to take out a hammer and start breaking the database physically. It's one of the big no-nos for me. I never use a shared table space. I will take your added defragmentation, added fragmentation within DB file per table and raise some more and still prefer the DB file per table. There's nothing more frustrating than altering a very large table within a single DB table space, only to find out it has grown twice its size to accommodate for the temporary rebuild of the new table, and never to release the old space. I've seen customers. I've seen many customers reaching 100% disk space usage because of this. It's a nightmare. It's an operational nightmare.
It seems like there was some ambiguity there, Shlomi.
Hey, Shlomi. Shlomi, I also assume that doesn't mean that TokuDB's file per index is necessarily more attractive even than file per table, right? Can I at least get you on record as saying we need to fix that?
Yeah, the problem I had with the TokuDB way of doing it is that I have many tables who have many indexes and also many partitions. So that multiplies to something like 20,000 different files, which kind of suffocates the open file limit, and it makes it, Linux can handle it, but not always MySQL can handle it, and we've had crashes due to that. So yeah,
that's
something. The extreme. That's the other extreme.
In TokuDB, at the moment, our only option is not file per table. It's actually file per index. And to Shlomi's point, if you partition, you multiply it by partitions. So something we are going to repair and make better in 2014. Back to something, Mark, you were talking about that I find as interesting we also look at fragmentation two ways. One is unused space in the files themselves, but the other is how the data lays out. And to your point, the best of efforts, even if you lay it out what you consider to be sequential underneath you, something like XFS could just be totally lying to you that what you thought was contiguous in a file is no longer contiguous. So a different challenge we face in TokuDB, we don't have fixed on disk size, so we constantly try to get better at not having holes in the file system, in our files that we can't reuse. InnoDB fixed block size. If it's 8K, if I delete that block, it's gone. I can always automatically reuse it. We round to the nearest 512 bytes. So you could write a 3 megabyte write, 3 megabyte and 1 byte, and something that's 3 megabyte and 513 bytes won't fit back in that hole. So we're fighting a different kind of fragmentation problem, which is slack in the file as opposed to not using up to 100% of the block itself.
Yeah, it's interesting you mentioned that, Tim, because it's good to highlight the two problems. If you can't recover space, your backup is more complicated than it has to be. But if you're diluted across pages, you can't get things like better memory fit and therefore better performance from what caches you have to have memory resident.
Yeah, and I think that's something like really to highlight here is that when we're talking about this, like, why is index fragmentation a problem? Like, why would you as a DBA care about this? And ultimately, the takeaway is, to Morgan's point, if you dilute your pages enough, if things are kind of spread out enough, MySQL can only cache data on that block, on that page effectively. So if you have a piece of data that could fit in one page and it's instead spread across 3, there's a chance that you're not going to be able to have that fit in memory, and you're going to be forced to do a disk seek just to answer any queries that depend on that information. And so then the other point, just kind of summing this up, was from what Mark had said, where if you have fragmentation inside of the index, where the extents are not adjacent necessarily on the actual disk, now you have to suffer a seek or another disk lookup just to pull a piece of data that is technically contiguous but is not actually written that way.
Mm-hmm. And isn't it most apparent as a DBA, if Inno at the moment supported file per index, like take it to that level, the real, and we deal with this with our users because we occasionally have people rebuild things. If you have an index that's a terabyte on disk and you drop and recreate that index and the user does a DU and notices, oh, now it's only half of a terabyte, like, it's an eye-opening experience. And then as a vendor, like, that, my user's calling me immediately, like, what is going on here? You told me you don't have fragmentation, but when I rebuild this index, it's 40% of its original size. So that, as database vendors, I think we're all doing our best to try to reduce that impact as much as possible. But nothing built, dropping and recreating indexes can sometimes be eye-opening, especially if the table or index has existed for a really long time and has a lot of churn. Lots of inserts, lots of updates, lots of deletes over time. It's a tough problem to solve.
So actually, to that point, that is, now that I think about it, that is like one of the few cases where some sort of fragmentation, either just in the table or in the index, has come up for my team, where we have a table that has very high traffic. It's effectively a queue, an event queue that happens. And on some downstream replicas, and it was specifically on our backup servers that were replicating, we would see this, where this table would just kind of grow in size, and it would be massively larger than the one that is on the customer-facing master at the time. And doing an optimized table or just a quick alter to reset the engine to InnoDB would shrink it down to kilobytes from gigs. And it's something that there's definitely some other stuff going on there that you would want to track down, but that is like Tim said, that is the most eye-opening experience when you realize you probably could free up a significant amount of disk space if this is a problem you're suffering from. And actually, to that point, so something I wanted to ask you, Mark, because you're Mr. Performance Schema in my eyes. Is there something in performance schema that would allow you to track this or see this information, either in 5.6 or future versions?
Not so much for fragmentation in InnoDB itself. I mean, in performance schema we do track file I/O and table I/O, but we don't actually track how the pages are being allocated within InnoDB itself. And there's really nothing very good out there for it. If you're using central table spaces, even in 5.6, you can use this InnoDB table space monitor. And I've pasted a link in the chat there. I wrote a blog on it years ago that lays down how to read the output of that. And that shows you exactly how the pages are being allocated and the tables themselves and things like that in the central table space. But unfortunately, it doesn't work for per table table spaces. And it's not going to be extended to actually work for that because it's been deprecated, as I understand, in 5.7. We could do a lot better. I mean, the data is there, right? We can get to that kind of data. We just don't have anything planned to actually do it at the moment.
To maybe give a 10-second explanation why it's deprecated. One of the features that we've mentioned that we're working on is a native InnoDB data dictionary. And as we implement that, the old interfaces, rather than updating them, where possible, planning new interfaces, as the table space monitors predated information schema and things like that.
Yeah, I mean, my hope is that one day we'll expose in the data dictionary how those pages are being allocated, who they're allocated to, and all of that kind of stuff. Very much like the table space monitor. And if you look at something like Oracle, right, they have like this DBA extents and all of that kind of stuff, which lays all of this out in very similar ways, and you can do some beautiful things. I worked on tooling with Oracle where you could break down exactly how pages are being used in data files and all of that kind of stuff per index, and you could see exactly the fragmentation maps of all of the pages and that kind of stuff. One day we might get there. I mean, I hope we do. We've got plenty of stuff to do, right? So we'll see. But going back to the per table thing, and I'll mention Oracle again. I actually don't believe that per table is the panacea, or per table files are the panacea that everybody thinks they are, right? Everybody uses them because of certain limitations that we've got in MySQL in not being able to actually shrink data files online or shrink data files at all, right? Or have multiple table spaces with files which are, you allocate your objects to however you want to, in the way that Oracle does. If you have much less files to handle from the operating system perspective, and also doing things like keeping LSNs up to date across all the data files, for example, you guys probably don't realize the overhead that can put into the system as well. Having much fewer table spaces and much fewer data files to actually manage from the database perspective is a really, really good thing, right? It's not a bad thing to have that kind of stuff. The problem is actually we don't have any way to shrink that. Like Shlomi said, you alter a 1 terabyte table and we have to shove another extra terabyte in there to alter the thing. If you could add a data file that's 1 terabyte online, and then do the alter, and then drop the data file afterwards when you know that it's empty, what's the problem, right? I mean, that's where the problem lies for the most part. It's not in these other things.
And that feels like just a very common problem you'll see in any sort of data store. And as much as it's like, yeah, you should be using file per table because it gives you more granularity to control your disk utilization and kind of where the data is actually like co-located effectively, and gives you slightly better semantics around. You could put it on different partitions and break out more of the things. Just thinking like in Oracle, like the Oracle RDBMS, you would define your table spaces and peg tables to those. And that's how you would get at that similar semantic of you would define, maybe a user table space for certain things, a temporary table space for others, and you'd be able to peg those on different mount points potentially or something. And so it'd be interesting, and the thing is like InnoDB, if you're not using file per table, you can define multiple IB data files, in the config, but one of them always has to be that auto extend. That's just going to explode in growth over time potentially if your data set goes big enough.
No, it doesn't have to be extend. I mean, you don't have to have auto extend on the data files. You can let it fill up if you really want to let it fill up, right, and it will stop.
Well, okay. Some of us don't have a death wish with our data, but
I mean, one of the things you'll see, even if you look at 5.7, for example, now, we have the ability to do a separate undo table space. We have the ability to do a separate temporary table space as well in 5.7 now. We're looking more and more at central table spaces that can be used for these different types of objects, for example. So,
Mark, maybe if I could paraphrase your comment. You're saying by using things like file per table or file per index, we're pushing things down to the file system or the level below, rather than choosing to do it ourselves. And maybe long-term, if we did it ourselves, we have more metadata and we could create a better experience. Is that what you're saying?
Yeah, in many ways. I mean, we push a lot more down to the files or the file system, all the OS and process perspective as well, like the ulimits that you've got for opening files and all of that kind of stuff. And just the overhead for opening, managing those things, syncing them all. There's a lot more overhead if you've got a lot of tables to actually manage all of those files than if you have a few key sets of table spaces with a few key sets of data files themselves as well. So they're trade-offs at the end of the day. I mean, most people right now, the right trade-off, I'll admit it, is to go with file per table because of the limitations of space and things like that with the central table spaces. But ultimately, I don't think that's the way that we should want to go. I think we should try and figure out the problems with central table spaces. They're proven to work very well in database systems like Oracle, right? And we should figure out how to make them well with MySQL.
Mark?
Yep.
Did you mention, as part of that explanation, so let's say I was using InnoDB, file per table, I create a table, PK only, insert a bunch of data, and then I build an index on that table. So let's pretend in the file system that all the blocks that captured that index were appended to the end of that file. And then 10 minutes later, I drop my index. Does Inno trim that file back if there's unused space at the end, or do Inno files not shrink and only grow?
It never does it automatically. So the only way that file per table space will shrink is if you either alter or optimize the table. So optimize table wherever it might be, which is essentially creating the table anyway from scratch. So it will never do it.
All right.
Sorry for the silence. I got a page that I had to look at, but real quick, I just want to pause. For folks, I don't know if folks that are watching are able to see the strip at the bottom here, and same with the recording, but during the last probably 10 minutes of conversation, a bunch of silly hats have appeared on people. I just want to take a quick pause and have everyone say something so we can see all these hats.
This is a penguin.
Mine's a tiger.
Mine is a fox. What does the fox want? Yay!
So just everyone's been silently dying because these people have been popping out and into the conversation to put them on.
These were definitely some of the coolest swag given out at the last Percona conference. And it seems like many of us, my wife tried to hide mine, but I found it. So yes, that's really all came from Percona conference last year. For anybody who's kind of curious about that.
Yeah,
I'm sure
mine is it's a giveaway from Vivid Cortex.
Right. Yeah. Okay. So focusing us back down to the topic at hand, I guess, just index fragmentation. And so, Mark, what you were saying, like, I actually wholeheartedly agree. I would like to see, what more discussion, or maybe just like what is the proper resolution around shared table spaces, because it's clearly been solved in some other RDBMSs, at least somehow, and it gives you a nice fine-grained control stuff. Because the other thing I think about too is, some of the weird problems you have and around table spaces currently in InnoDB, and it's possible these will be addressed and improved once the InnoDB data dictionary takes hold and has a more strong suit in the environment. But like currently, you have to sometimes things can happen where you have to discover the table space ID of a file per table file and discard it and re-import it or something if like weird things happen where it falls out of sync with what's kept inside of the actual table space. And things like that. It doesn't happen often, but there are like a few cases where as a DBA you might have to actually go in and like recover something that got really weird or corrupted in a way that it fell out of sync with what is kept in the main system table space. Mm-hmm. And the thing is, like, I feel like the InnoDB data dictionary might actually provide that resolution, but I see Morgan smiling. I don't know, because it was one of those. It was just we started talking about it, but I don't know if there's any actual work being focused heavily into it yet.
But is the argument against putting all your tables in a single table space in InnoDB anything more than space? Because I can only speak to the users and evaluators I talk to for our stuff, right? And the one, Shlomi makes a great point. We need more flexibility, because you can certainly come up with scenarios where I've got a user in production with 2.5 million fractal trees. So they've got 2.5 million files on disk for my engine. So that's a real problem. Shlomi described something that I agree with him as well. But what people love about file per index is, hey, I'm getting low on space. I can live without that index. I drop the index, and immediately my gratification is reclaim space. Whereas you put the indexes in the tables in one file, and you drop an index, and as Mark just explained, that file's not getting any smaller right now. Or you put a bunch of them in a table space, and you drop a bunch of tables, and you don't feel like you have more space. You have more usable space in your database, but maybe you needed that space for something else on your server, and you're kind of stuck. So, I'm curious. We are making efforts this year to consolidate multiple, put everything for one table, including its indexes in one file, similar to as well as potentially allow people to do table spaces, because some people have tiny little tables and just putting 1,000 of those in one file is fine. But I'm nervous about the other side, which is right now that you drop an index, it's an unlink of a file. We don't even have to run it through a block allocator, because even that in Inno takes time, right? Inno's got to go through internally and say, hey, all these blocks are now free. And it sounded like Mark said earlier, there really is no API at the moment to ask Inno in a file how much free space there is, right? That API isn't even exposed at the moment. So, I asked this because I think half the people who are more on this hang up are ops, are real world people, not a person making a database for real world people. So, how do you deal with that? You need space on your server, you drop an index, but it didn't actually do anything from a DU perspective.
I wouldn't mind using the shared InnoDB table space if it's reclaimed space, if you gave back space to the file system. Then I would only just require some visibility into the internal allocation of space per table, which would be very informational. Whereas with InnoDB file per table, I get that roughly just by looking at the file size. I wouldn't care if it was single or multi, if only I felt I have control over this space and that things are acting reasonably. So when I drop a table with InnoDB shared table space, I know that that space is not going to be reclaimed by the file system, and moreover, I don't know how, if at all, is it going to be reclaimed by new tables. I know it will, but how much of it? So I don't get as much visibility as I would like to. So as long as I can trust the space to be reclaimed, either automatically or by vacuuming the database periodically, I don't care. And as long as I have visibility into what's going on, that's fine. I don't mind. I don't care what method is being used.
And actually, I want to echo exactly what you're saying, Shlomi, which is like realistically, if we do have everything in a common table space, even if it's just I drop it and then I have to run like some sort of compaction command that will make it kind of do an internal space reclaiming, like that would be like super ultimate best case because that allows you to get that free disk space kind of thing as an operator. But then the other point that Shlomi was saying was, maybe the initial step is just having the metrics that you can have, so that you can trust that, I've dropped this index in a shared table space, and InnoDB knows that there is free space there, so I will trust that InnoDB has, 2 gigs of space that I can use for something, instead of, I dropped it in, I hope there's enough, contiguous space available for it to allocate new data in. And so the other thing that I did want to mention too was just a lot of the work that Jeremy Cole had done with the InnoDB Ruby parsing stuff he put together. I'm not sure how many folks got to see his presentations on it. If you haven't, just look up the blog series, look up his presentations from the conferences. It's absolutely stellar work. And it's one of those, you're parsing a large data file with Ruby. It's going to take a while if you have like, a 200 gig table space or that you're ultimately opening. However, I mean, at the last Percona conference, he did demo like some iterations on the tools where you could have it print out contiguous space that's free, contiguous extents, and do some nice just kind of color coding to start to give you some of those metrics. And it's one of those, as a first step, that might be, maybe that's the place to go where you have a replica, or well, that's a replica wouldn't even help, but maybe you actually run these tools on the data files you have available periodically just to get a rough idea of what things look like. And that's like the first gentle step towards it, I think.
Yeah, I want to echo that as well. Jeremy's tool is absolutely, it was a joy to see it in action, and it produces round ASCII corners. So, well done.
Yeah, the pictures are amazing, and they are in the repo, and I will make sure I drop a link to those in there, and that's Jeremy Cole's repo for InnoDB, A Journey to the Core. And if anybody has not seen those, it's been going for 2 years, and just the slides are amazing. And the repository itself has a folder called InnoDB Diagrams, which I actually find myself referring to every now and then when I run into something tough. And it is fantastic, and everyone should go check that out.
So I did want to chime in. Morgan actually dropped the link. There was this Facebook talk done on InnoDB defragmentation. So the link for this will be put in the notes. But yeah, it sounds like this is actually kind of covering at a high level the stuff that we're looking at, and how Facebook addressed this. Because if I remember correctly, and guys, correct me if I'm wrong, but Facebook, they actually don't use file per table, or they were kind of against it because of how it uses up the space on their servers. And so my understanding was like, that's why this was a very big deal for them, because they have a large server farm. They just have things kind of rolled out there, and it's one of those, a small change here or there, right, deployed across the board is huge savings.
Jeff, my understanding was actually the opposite. They started with shared table space, and they moved to file per table. And when they were moving, they had to fix a few bugs, like stalls when extending file per table spaces and things like that. And they contributed those findings back, and a lot of those fixes went into 5.6, and it's actually the version that it became the default in. And I do think that's what they're using. And the argument generally for performance semantics is a little bit tough, because either side can be better or worse, but having a smaller backup by being able to reclaim space is useful operationally. I think that was one of their motivations, if I recall correctly, to switch.
Okay, yeah, that sounds right then. Okay, so any other commentary on fragmentation? Everyone seems kind of quiet. Mark, you were saying some stuff in the chat room if you want to chime in about that.
No, waxing poetic.
Okay, well, we've got about 10-ish minutes left, so I guess it's probably good just to maybe start on the next topic, which was around networking, and what kind of stuff a DBA should know about the networking layer, commands you would run, TCP dumps, like the immediate one that comes to mind. And I'd actually love to hear, John, Jeremy, Shlomi, just operationally, what does a DBA need to know about the network layer when operating, MySQL or something?
I can talk about that a little bit and also bring on that. So definitely, TCP dump is definitely one of the most valuable tools in a DBA's arsenal. I can't imagine how many times I've had a problem solved out by just doing a TCP dump and looking for network problems, because network problems do happen and people don't realize that. And understanding not just how to use TCP dump, but the basics of the TCP flags, SYN, SYNAC, FIN, your basics of the handshake, as well as sequencing is all very, very important for troubleshooting that stuff. Something I'm starting to come across a lot more often is that I'm noticing that with faster I/O, like SSDs and flash, is that the networking is starting to become a bottleneck, and that the old idea that 1 gigabit networking will almost never be saturated by a database is becoming an archaic idea. It is definitely something that when people start seeing random pileups of queries and you're just not understanding why, you may want to start looking at your network saturation as well. And some of the things I've seen this manifest as is percent util on disk, for example, is going to be saturated with 100%, but you're going to be doing a trivial amount of IOPS because it actually ends up being bottlenecked by the network itself. So be aware of that. Other things with the networking, ngrep. Ngrep is fantastic. It's a tiny little tool, but one of the nice things it does, much like T-Sharp, the CLI version of Wireshark, is allows you to decode the protocol on the fly. And what's that good for is sniffing people's passwords and debugging authentication issues, as well as, for example, something we see a lot nowadays is client-side database timeouts. And so the fun part about those is that things don't happen to make it into the slow log or other things because the client is preemptively killing the connection. And ngrep can be fun for finding some of these queries that's dying from the client side as opposed to from the database side, because you don't have all that information, and maybe that's a little abstracted for you for whatever your situation is. I think that's what I got on it. That's definitely my highlights of it. Make sure you know the basics of a TCP handshake, know the flags, start watching for saturation because it is becoming a bigger deal with faster I/O. And fun tool is ngrep. If you don't know it, you should know it. And once you know ngrep, you should move on to T-Sharp, which is the CLI version of Wireshark. That's my thing. Anybody else? Morgan, you seem to be nodding your head a lot.
No, that was great. This was partially my question. I feel like as I've progressed as a DBA, I've started to learn storage, and I've kind of had to, but I've never really learned network. And I wanted to ask that question, what to know from networking. That was a good overview. How do I step over the line a little bit more to be a better DBA?
I had a networking team, so I had that benefit. Also, just from a previous life, I was a sysadmin and did basic networking and routers for a long time, so that was part of it as well. Where do you start with this? A lot of it just is, I think the Wireshark GUI actually helped me a lot understand things, because you could pull the RFCs up, and that is definitely like the place you want to go. Is look for your RFCs. They sound boring and they make you want to just die because they're so bland, but they are really important when looking stuff up. So what you do is you take Wireshark and you start learning the basics of how to use Wireshark, and it gives you a nice GUI, a lot of clicky things to go through. But then what happens is it starts highlighting things in red, or you start noticing abnormalities, and you go, what's that really mean? And then you start correlating it with the RFCs to understand what the flags really mean, the ordering of things, and what each section means. And then after, I guess just like everything else, with enough problems happen, you end up starting to see common patterns of where things fail and how they're picked up. I would say, honestly, just grab your basics of whatever your brand of networking is. Grab their 101 book, like your CCNA book, or I don't know what the Juniper equivalent. I'm sure there's equivalents for anything, but grab those books and just start reading through them. OpenStack has an interesting walkthrough of the basics of networking as part of what's the part of OpenStack that does networking? I forget. Anyway, the manual for that does a ton of deep diving into how networking works, because you need to know it. And if all else fails, start managing IP tables, and you'll learn real quick.
So something that I did want to chime in too was, like John said, Wireshark is probably the best way to learn this stuff. But the thing is, if you turn Wireshark on just for the first time on your computer, let's say you have a MySQL D running on your MacBook, for instance, there's going to be a lot. There's going to be a lot of stuff in there you don't care about or don't even know about, and it's learning how to kind of trim that stuff down. And I would actually say another thing is just find a TCP dump just Google around for TCP dump with MySQL. Plenty of people have blogged and written about, like, I have this problem, I need to figure out what's going on. A lot of the Percona tools were built so that they could consume a TCP dump output to do things like slow query log analysis and stuff like that too. So you could find examples of doing it with those. And I mean, yeah, this is the other like very interesting part, because we've spent a lot of effort as DBAs and engineers working on MySQL trying to understand how we can better instrument the server to see what's happening with it. But one of the very interesting conversations and topics around this was it was stuff that actually Baron Schwartz did a lot of talk around, which is if you sample traffic on the TCP layer, basically TCP dump almost, as they're going into MySQL and watch for the response coming out of MySQL, then you can start to gauge, outside of the server, what's it doing, how much work is it doing, what kind of things is it figuring out, and that also gives you kind of another metric that you can almost look at to see, what's the actual throughput, what's the server capable of doing if I just throw X at it. Granted, there are other things going on inside of the MySQL server, and that's where you would have your addition, all the other tools that we already have to know, like, is there background threads doing work, are there things doing this or that, and then it'll help you try to figure out, like, what's going in and what's going out, and getting a really good understanding of what's happening.
Definitely, and I completely agree with Jeff on the just learn by Googling, because I think one of the biggest things I ever did was just learn tons of examples of how to get data from TCP dump, and then from there, how to read the data. And so, like, before you even get started on learning, like, how to read the packet payloads or decode them, or snap lens, anything like that, just learning your headers, again, for reading the basics of it, is you're going to start seeing problems, and you're going to start recognizing them at the network layer. And it's fun because that becomes a pretty agnostic tool throughout your career as just a technical person. It doesn't really matter if you're working on databases or web servers or load balancers or anything. You learn to do TCP dumps and sniffing the network, and you can learn what's going on anywhere in the internet. And that's just how things work, right? So definitely agree with that. Google for TCP dump in MySQL. You'll find tons of examples, and there's good stuff there. And so my previous note, I talked about network saturation, but I didn't actually give an easy tool to find it. And off the top of my head, I want to say iftop will show you what your current rate is. I don't know if there's anything simpler. Yes.
For simplicity, John, I use atop. It gives you basically the top view, but at the very top of the top view, you have a list of, like, all your CPUs, your memory, your swap, your paging, and your network. And you can see network utilization based on each Ethernet device, and it'll actually highlight in red if you're starting to exceed, I think, like 90% or something like that. So real easy at a glance. And I think atop is on EPEL if you're on, like, CentOS or something.
Cool.
What I like to do is old school. I use SAR. I use SAR-N, and that will help you look at the actual counters for, like, overruns or drop packets or whatever. If you have SAR or systats or whatever running and you're collecting metrics, you can look at the history, but you can also run it just on the fly, like SAR-N, edev, like 1 for 1 second intervals, and you'll be able to see if you're actually implementing, like, drop packets or something.
Yeah, and that's the other thing is, honestly, just collecting any sort of networking information over time. I'm not sure if the Percona Cacti plugins have this out of the book, or if Oracle has a prescribed monitoring solution around this. But, in our case, we're at Box we use OpenTSDB, and we have a network interface collector that's running, and so we have metrics around network bytes going in and out of a server, and so that's one of the other things that we do look at is, when there's a spike in the server. After digging through, one of the things is, was there actually a flood on the network layer? And then that's when we actually go the next step of looking at SAR around packet drops and lost packet information. And if it's something that happens periodically, then maybe you actually set up some sort of a trigger that actually runs TCP dump periodically. And I mean, so that's something that we have. We have TCP dump automatically running on every server for various data collections that we do.
Well, I'm loving this conversation. I'm learning a lot. I'm hardly a network expert. We have great ops guys sitting next to me, so that I don't have the need to learn all that stuff because they're so great. But one preemptive thing we do is we just compress all networking to and from MySQL. So we use our JDBC connectors, use compression equals true, Our slaves use the slave compressed protocol. Everything, as much as we can, is compressed, and that actually saved the day a couple of times when we realized that we were not using compression and the network was bad, and just dropping down to compressed protocol just allowed us to make it through the bad network. So why not take this step in the first place?
Yeah, so anything else, guys? And actually, I'd love to, Mark, Morgan, Tim, anything on your side that you guys can think of that, just networking layer stuff that maybe a DBA should know from your perspective.
Maybe as a question, I have my thoughts. But what would you say is typical latency for a network? Everyone sees ping, but how do you interpret it? Do you think 0.1 of a millisecond is considered fast these days, and half a millisecond is typical?
Oh, wow. No, that's an extremely good question, and honestly, it depends on the network that you're passing. Like, for me, and inside of our network, we have 40 gigabit links or something. I have no idea, but very fast gigabits, lots of them. And so anything that is, a millisecond is horrendous inside of the network. Like, it should be sub-millisecond. A millisecond is how long you expect a query to run. You should be able to get it back to the user faster than that too. But if you're going through AWS, I actually have no idea. I feel like AWS, you'd have to accept a little more ping buffer there. But again, that's something I defer to anyone who might be running AWS to answer that question. Another tool that I did just think of, though, was so you mentioned ping. Ping is like the super simple check if something's there, some flags to make it run really fast and stuff. But another extremely valuable tool that I have found is MTR, which runs a trace route and pings on every link between you and a destination. And so, from a database, maybe not as valuable, but things like if you have clients that are periodically seeing slowness getting to your database server, especially if you're in a cloud-based environment, hop on whatever client machines you have, run an MTR to your database server, and see, how many hops is it going through? Is there some sort of gateway or link between you and the database server that is actually causing the slowness? And MTR would allow you to very easily see that in a nice, simple interface. So that's all I got. You guys are talking about net buffer length. Does someone want to chime in on that?
Yeah, we mentioned net buffer length and backlog. I was actually wondering if Mark could talk about those. That sounds odd. Backlog is one of those things that most people don't realize is really, really important, but it's like the default tuning is made for the 90s. So it's actually one of those things you end up setting a lot once you hit a high concurrency.
I think the default tuning was set for the 90s. 5.6 improved that, if I'm not mistaken.
Yeah,
a lot of the defaults changed and are much better.
Just to kind of explain backlog, it sets the number of connections that can be accepted with the MySQL server. And if you have a hell of a lot of connections that come in per second, so if you're talking like 500, 1,000, 2,000 connections per second, if you don't increase your backlog, then you can start pretty much getting network errors from the clients themselves, seeing actually much longer connection times and all of those kind of things. Somebody said, how do you recognize it? And it's quite hard to recognize it from the server perspective, right? It's something that you've got to, in many ways, instrument from the client perspective, know how long it's taking you to actually make a connection to the database itself. So that's a hard one to tune if you're just pulling from the database itself, but it's an important one for if you have a lot of connections per second. I mean, if you're over 500 to 1,000 connections per second, then if you haven't tuned that, then you should go and tune it right now. I mean, it's something that you should definitely think about. The net buffer length one is an interesting one. So for each connection, they get assigned this buffer, which is net buffer length in size first and foremost, and then that grows up to max allowed packet as the different statements that you've got get executed. And the question was, how should you set it? Is there a reason to set it? And pretty much the only reason I've seen is if you are constantly executing queries that have very large packets, right? That go push the packet lengths, or so you're doing a large number of multi-row inserts, inserting a whole bunch of things all the time, or and actually having large result sets that are coming back as well, because we actually have to essentially mal off more space as the buffers get allocated internally in the server itself for connection. So it can make a little bit of a difference if you are in that situation to just increase it a little bit. Otherwise, most people really don't need to do anything with it, right? Most web shops themselves are insert a row, select a small amount of rows. They don't select huge amounts of rows or anything like that. So for the classic web shop, probably don't need to do anything with it. But if you've got something like a data warehouse, which is pushing and pulling huge amounts of data, then it might be beneficial to do it then.
That was going to be more or less my explanation as well. There's an academic case of memory fragmentation where you might want to tune it up to prevent having to malloc extra memory up to that max allowed packet. And the only proof that I've seen of that academic case is I saw a memory leak once where a customer managed to avoid it by just setting a large net buffer length. But that bug is long and fixed for 5 or more years. So I would never tune it.
Okay, all right. So we're actually at the end of the time limit now. So I think I'll rope us in. Definitely got some good stuff out of this. I hope folks picked up some cool things that they can try out. And I think I captured all of the commands that were called out. Things to do inside of the notes. So beyond that, I think next time one of the hot topics we were talking about before we started the broadcast today was postmortems and just kind of postmortem culture and things like that. So hopefully we can do that next time. And if there's any other topics, I guess folks would want to talk about next time outside of postmortems. Okay, I'll take that as a no. And if you get any, definitely hit me up offline. And beyond that, yeah, thanks for coming today, everybody. Thanks for participating, and we'll see you again in 2 weeks.
Jeff, maybe to finalize, what's the Twitter account again? Just so if anybody has any questions or something they'd like to hear us talk about, what's the Twitter account again?
Gotcha. Twitter account is DBHangops, DBHANGOPS. So
send any questions you got for us, or any complaints or suggestions, or any nagging operational things you'd like us to bat around for a little bit. Love hearing feedback.
I will happily reply, John, on every single question.
That's fine. I think I have to reset my Twitter password again now. But
alrighty, cool. Well, beyond that, thanks very much for coming today, everybody, and we'll see you again in 2 weeks.
All right, bye.
Thanks, bye.